let's take out the assignment from last night, and we'll go through some of this here as a group. So feel free to look at your paper, to write in correct answers or update things or whatever. Okay. Okay. Which number do we start with? Is it 9? So, for number 9, what did you guys do as your first step here? I love that idea. That's the easiest first step you could make. Because what's going to happen now? And you're left with just sign. I can't get simpler than one thing, so we done. Okay, on to 13, because we're doing every other odd. So what was the first thing you guys did for this one? So hopefully you noticed that 1 plus tangent squared was the same as secant squared. Good. That's what I would have done first also. And then what did you notice? I noticed that secant over cosecant was the same as tangent. So secant squared over cosecant squared is the same as tangent squared. So skip 15, go to 17. We have sine x times cosecant of negative x. What did you guys do first here? So I heard some people say the even odd one, where we're going to change cosecant of negative x into negative cosecant x. So that's fine. Then what did you do? Yeah, we can rewrite negative cosecant as negative 1 over, oops, daisies. Let's write that as sine x over 1, and then over sine x. And you're left with negative 1. Well, you can't cancel cosecant x and cosecant negative x. So you still have to do that odd-even identity. So you still need to do that odd-even identity because the cosecant x is not the same thing as cosecant negative x, so they don't cancel out immediately without applying that property first. Is that okay, Julia? Sure, if you believe me. Well, if you think about it this way, if you have like square root of 3 is not the same thing as square root negative 3, right? So there is a difference there. Gabriella? Right, and that's what we did. Right, that's that step right there. So, yep, you did exactly what we did, so that's good. I like it. 19 we skipped. 21 is sine squared negative x plus cosine squared negative x. So what's the first thing that we did here? This is a little bit tricky because you have to really interpret what sine squared negative x means. Yeah, so I'm going to do this just to demonstrate to you kind of what or how I'm going to think about it. So remember we talked about how instead of writing them this way, we saved ourselves a parenthesis and wrote it like sine squared instead of sine of x quantity squared. So I'm going to go back to this notation because it makes a little bit more clear what we're about to do. But at this point, now I would apply the odd-even properties. Everybody okay there? And what is negative sine x squared? For what? If you look at the odd-even identity for cosine, cosine of negative x is just cosine. So it appears that I'm missing one, but not according to the identities that we proved yesterday in the identity sheet that we have there. So it is correct. So if I look at this chunk here, what does that simplify down to? That's negative sine x times negative sine x, right? Negative times negative is positive, and sine x times sine x is sine squared x, right? And then obviously the other one is cosine squared x, and that all just gives me 1. No. So if you wanted to do that, you'd have to do a change of variable. But if you say like let a equal negative x, you can say that sine squared of a plus cosine squared of a is equal to 1. But I would require that you at least did that change of variable thing. So 23 we skipped to 25, and this one you probably looked at and went like, oh my god. But it's going to be okay. Yeah, I hear somebody over there being like an Eeyore there. All right. Well, I guess I would start by just distributing that negative sign. And then after I do that, I can drop all of my parentheses. Well, the big parentheses anyways. Everybody okay with that idea? I guess I meant to write that in red. I'm just going to recopy the same thing. I'm just going to write it in red, though, because that's what I've been doing. I don't know why. I'm just being fastidious. Everybody okay with that first step that we did there, just distributing the negative? Okay. What did you want to do next? Yeah, so hopefully you notice that for both secant squared and cosecant squared, we have a Pythagorean identity for those. So we said secant squared was tan squared x plus 1. And cosecant squared, we said, was 1 plus cotangent squared x. And what do you notice happens now? Tan squared and negative tan squared. Cotangent squared, negative cotangent squared. And we're just left with 2, as some of you shouted out. The 1 plus 1 that's left right there. Skipping 27 and going to 29, we have sine x times cosine x times tangent x times secant x times cosecant x. Jeepers creepers! There's a lot of things here. What do you guys think I should do first? Yeah, I love that idea. That's what I would do. So I'll just write everything in terms of sines and cosines. And in general, like, if you're not sure what to do, that's usually not a bad thing to do. And what do we notice here? Yeah, so, and we're left with sine over cosine. And as you might have remembered, that was just exactly what tangent was. Everybody, we doing okay with these? Sort of. I know it's new and it's different, so I'm trying to make sure that we're going slow. If you need to ask more questions, though, please stop me in the middle of things, and like we can play the what if I did this instead game and do some of these that, like, in a different way. And if there's something wrong that you're doing, I'd be happy to like stop you and tell you what the wrong thing is and explain why it's wrong. Or if what you did was right up into a point, we can kind of show you how to finish it out doing the way that you've done it. Because again, a lot of these, there are multiple ways to kind of get to the correct answer. It's not all one way or the other. So 31 we skip. 33 though, we have 1 over sine squared plus secant squared over tangent squared. Any ideas here? I heard someone say a common denominator, which is fine to do, but I'm interested in, Sebastian, what did you suggest? Okay. Yeah, I'm now less interested. I thought you said something different. I mean, that you could do that. There's nothing wrong with doing that. But there is a quicker route yet than doing that. Sophia? Ooh, I like changing the secant squared, but I want to use the Pythagorean identity to change into tangent squared plus 1. That's what I think I want to do. Now, all of those things that you guys just said to do were all okay things to do. There's nothing wrong with going those routes, and you will likely get to the correct answer in no more steps than I will going that way. But this is the one that I would have wanted to do first. And the reason I like that, or liked that idea is because it allowed me to take that second fraction and rewrite it as a couple of different fractions. Everybody okay with what I did there? I just took that one fraction with a common denominator and wrote it as a sum of two fractions with a common denominator. Right, so I took I just took like this fraction plus this fraction. Well, they can now that I've written it this way. So now I'm going to write this as cosecant squared, that's 1 over sine squared, plus cotangent squared, plus 1. And I notice here, this part is cosecant squared, so I end up with 2 cosecant squared x's. Now, let's do that same problem again, doing some of the methods that you guys discussed doing, just so we can see a different route, because it is certainly not unreasonable to do it a different way, but it requires kind of more fraction-y nonsense. I chose that way because it seemed like it was going to have the least fractions involved, and you notice within 2 steps I was down to no fractions. But there's nothing wrong with doing it another way. So maybe you said, oh, let's try to just start by rewriting everything in terms of sines and cosines. So maybe I start by writing this as secant as 1 over cosine squared and tangent as sine squared over cosine squared. Now, when I have a fraction of a fraction like that, how do I simplify something like that? This is really a division of fractions problem, right? So we take the top, that part is going to stay the same, and we multiply it by the reciprocal of the denominator. Everybody's okay there? Again, hopefully you remember that from Algebra 3-4 last year when you added and subtracted rational expressions. Somebody should have shown you that last year, right? So now we have 1 over sine squared plus, what's left here? Just 1 over sine squared. If I add those together, they have a common denominator, so I have 2 over sine squared, which is just 2 cosecant squared x. So you could do it that way. Let's do it a third way, just to kind of cover our bases here. So maybe you said, well, I'm going to start by just making common denominators. So nothing wrong with that approach. So you might have said, oh, this is what I want to do first. I'm going to make a common denominator and add these fractions. Sure. Sure. Yeah, if that's what you want to do, that's okay. So when I do that, I get tan squared x plus secant squared x sine squared x all over sine squared x tan squared x. Is everybody still on board with this? Doing okay? At this point, it seems like the best idea would be to write things in terms of sines and cosines, I think would probably be the natural next step. Does anybody have something they'd rather do at this point? It's okay to volunteer things. Yeah, I've just done the same problem 3 different ways to just kind of, seemed like in the beginning when I asked for what people wanted to do first, there was a lot of disagreement about what to do first. So I've just kind of attacked this, doing a couple of different disparate methods to show everybody that just because I didn't choose what you chose to do first doesn't mean that you're doing anything wrong. So notice that here we have sine squared over cosine squared. Hopefully you recognize this as tan squared. So you have now 2 tan squared over sine squared tan squared. And we end again at 2 cosecant x. So we've done that problem 3 kind of distinctly different ways. There's probably still some more ways you could have gone about doing it to get to the correct answer. Of these 3 ways, I still think that that first way, what? She's in B11 because that was my 7th hour and I switched courses I'm teaching and now I'm in this course for 7th hour. So B11 is where she's at. That's okay, no big deal. Yeah, I still think maybe the first one was the simplest one that we did, although that second one wasn't too bad either, right? This third one got a little hairy at a point, so that got kind of big. All right, enough with that one. What number are we on now? 37, you said? Okay. So we have secant x over sine x minus sine x over cosine x. What do you guys want to do as your first step for this problem? Okay, we can do that. Now, it's not a bad idea to do this, but so we have that. And then what do we need to do next? This thing looks pretty gross. Let's simplify that down, right? Technically, this is a fraction of fractions, right? It's 1 over cos divided by sine over 1. So how did we simplify a fraction of fractions? You have the top times the reciprocal of the bottom. So I basically just have 1 over cosine x sine x minus sine x over cosine x. Okay. Everybody on board to here? What do you think now? Yeah, you can't cross those signs out because of the subtraction symbol in between them. You need an addition symbol to cross those out. Instead, what I would do is make a common denominator and do the subtraction of the 2 fractions to try to get 1 fraction. 1 fraction is simpler than 2. So notice that that common denominator would just be cosine x times sine x. So if I just multiply the second fraction by sine x over sine x, I will have a common denominator, right? So my new fraction is this. What is my numerator for this new fraction going to be, though? Yeah, 1 minus sine squared x. And do you remember anything about this fella? Yeah, so remember we had the Pythagorean identity here, and if we subtracted, say, sine squared from both sides, we got this identity. And that's what we're going to use up here. Sure. So now we're to here. What do you guys notice? Yeah, we have some canceling that can happen, right? Sine squared x, yes. Correct. So Julia says equivalently, we could also say sine squared x equals 1 minus cosine squared x. And you can treat those just like an identity and just use them without deriving or proving them or anything. You can just drop those in. Those are pretty common. And in fact, they're probably more useful either than P2 or P3. So what are we left with up here now? Which is this was all like an aside down here. Just so we're looking back at this tomorrow or something, we're not confused. All right. Next one is 41. Is that right? Cotangent. That's okay. So for 41, they were very nice and put this extra set of parentheses here that really there's no real reason that these need to be written, but they were trying to get your attention. So what can we use here? Yeah, I can say that 1 minus cosine squared is sine squared, right? Now let's look at this thing here. Doesn't this look to me a little like if I think about that sine as just a variable, this looks a little like a quadratic, right? Don't you all kind of agree? Yeah, and we could factor this quadratic, right? How does it factor? Yeah. And since y was that, we can do that, right? Which is the same thing as, and I guess this is probably as good as we can do because we got it down into one thing. Why can't I just say 1 minus sine x equals cotangent? Or I'm sorry, cosine. Yeah, because it's not squared, right? If it was 1 minus sine squared, you could call that cosine, but this one isn't. That got a little weird order for that one, but okay, whatever. And then we skipped 43. We go to 45, correct? I have a feeling I'm going to be doing something similar here. Yes, sir, you may go. Bye. 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 So I see a very similar problem. So the way that I'm going to think about this is I'm going to think about this as minus 4 times 1 over cotangent. And what is 1 over cotangent the same as? Tangent. And then I have sine x over 1 times 1 over sine x, and that's the same as 1. So really I have 4 tan x, or tan squared x minus 4 tan x plus 1. That looks a little like a quadratic. So if I say, what if y equals tan x, I have 4y squared minus 4y plus 1. That looks suspiciously like something that can factor. Does anybody see how to factor that? Two y minus 1 times 2y minus 1, which is 2y minus 1 squared. And since we said y was the same thing as tangent, we have that. Okay, so you're asking if I can do this, right? Okay, so my question for you then is, what's 1 plus 2 squared? That's the same thing as 3 squared or 9, right? Is that going to give me the same thing if I do this? Nope. So is it okay to distribute exponents? Nope. If you decide you want to do that, we can meet after school. I will give you $5, and you give me $9 back, because you're saying that they're equal. And we'll do this until you have no more money and I have all your money. Okay. And then the last one is 49, I think. Is that right? Okay. Are we almost out of time here? 9 minutes. Oh, good. Okay. This one, who's ready to get sneaky with me? Yes, I've been waiting all day to get sneaky. So, I'm going to use that derived Pythagorean identity to rewrite sine squared as 1 minus cosine squared. Who was ready for that? Nobody was. Now, let's look at 1 minus cosine squared. If we say that cosine squared is the same thing as y, look at that numerator. Does that factor? Yeah, what kind of factoring can that do? I heard somebody say it. Difference of 2 squares? That's dots, right? And that's as good as we can do. DOTS is an acronym. It stands for difference, D, O of T2 S squares. DOTS. It's a neat acronym because I use difference of 2 squares. Happens a lot. It's a useful technique. Okay, in general, do you guys have questions on this? Who still feels like they need more practice? Yeah, a lot of us. Okay. Do the other set of odds. So if you were like, if you did all the odds on accident, you're already done. So do the other set of odds. So you're going to do like 3 through 40, or what is it? It'd be 11 to 47. Every other odd. Did you guys feel a little bit better after going through some of these? That's the plan.